And theory of screw jack, where we see the screw jack diagram and derive the relation between the load and effort, that is P equal W into tan of alpha plus pi when load is lifted. So now coming to this is this is the screw jack experiment setup. Here we see the cylinder itself acts as a nut. So because we know already screw jack consisting of nut and screw rod. So this is the nut. So inside it is having internal threads. So coming to this one, this is the, you can see here the screw rod. So it's having external threads of pitch 2.5 mm. Okay, here this is the load platform where we keep the loads. So this is the load we keep here. Okay, then we find the how much effort required to raise the load. So by keeping these are the effort weights by keeping here in the load hanger, here in this load hanger. Okay, this is the load hanger. So the weight of the load hanger is 200 grams. While note down the effort value, so just add the 200 grams to your effort weight, and so you should add the load platform weight of 500 grams to your load. So with the help of this is the observation table of simple screw jack experiment. Here you can see the simple serial number. So here this is the load column, load of W, it is denoted by W, the units are in grams. Here you can see you should include the weight of the load platform, that is of 500 grams. Already I told to you earlier. So then here you note down the effort value, that is in grams, symbol is P. Here also you should include your effort value of hanger weight of 200 grams. So then this is the velocity ratio. So the velocity ratio formula is distance moved by the effort by distance moved by the load. Again, distance moved by the effort I can measure with the help of tape. So in the next I will show how to measure the distance that is moved by the effort. So then the distance moved by the load, the formula to calculate is equal to number of revolutions into pitch of the screw. Here the number of revolutions I am considering 2 revolutions. So then the pitch of the screw already I told you that is 2.5 mm. So 2 into 2.5, that is 5 mm. So I know the value of distance moved by the load. I don't know the value of the distance moved by the effort. Okay, in the next, so I am explaining how to calculate the distance moved by the effort. Then I get the velocity ratio value. So again coming to the mechanical advantage. So mechanical advantage, the formula is that is equal load by effort. Here load value, here effort value, just calculate that we get the mechanical advantage. After getting the mechanical advantage and velocity ratio, so the efficiency, that is formula is mechanical advantage by velocity ratio. So I am measuring how much distance moved by the effort with the help of tape. So now how much distance, that is the effort hanger from the floor, that is 620 mm. Okay, now I am note on the value, that is 620 mm initially. So now I am completing the 2 revolutions of the screw jack. One, okay, 2. I am completing 2 revolutions. So now I am measuring how much effort hanger from floor, the distance, that is, okay, that is 45 mm. So then 620 minus 45 mm. So we get 575 mm. So this is the distance moved by the effort for 2 revolutions of the screw jack. Okay, now I am note on the distance moved by the effort value. So just now we measured using tape. So that is 575 mm for 2 revolutions of screw jack. So we know the distance moved by the load for 2 revolutions, that is 5 mm. So the formula to calculate the velocity ratio is distance moved by the effort by distance moved by the load. So here the distance moved by the effort is 575 mm. Okay, by distance moved by the load, that is 5 mm. So then I have got 125 mm as the velocity ratio. Okay, so velocity ratio is same for screw jack experiment for all readings. Okay, now I am keeping the weight of 2000 grams on load platform. So now my weight is, anyway already I told to you, so 2000 plus should include the weight of the load platform also, that is 500 grams. 200 plus 500, so 2500 grams is the load I am keeping here. So now I am keeping the effort value, effort, this is of 200 grams split weight. I am keeping in the effort hanger. It's not moving. So you should take the reading of effort value exactly at the point of moving the screw jack. Okay, now I am keeping one more weight of, it would be 50 grams. Sorry, I am keeping weight of 100 grams. Okay, it is moving with very high speed. So, but here you need to take the, consider at the point of moving. That is the reason I am not considering this 100 grams weight. So now my effort is 200, I am keeping here, plus should include the hanger weight of 200 grams also. 200 plus 200, that is effort value is 400 grams and load is 2500 grams. Okay, I am note down the values of load and effort, that is from our experiment. So here the load value is 2000 plus weight of the load platform, that is 500 grams. So total is 2500 grams. Now effort value is 200 plus hanger weight is 200. Total is 400 grams. These are the load and effort values. Now I am calculating the mechanical advantage. The formula is load by effort. Here the load value is 2500 by effort, 2500 by effort value is 400. So then I am using calculator to calculate this value, 2500 by 400. So, okay. So that is 6.25. This is mechanical advantage. Anyway, we know the velocity ratio. Just now we calculated the velocity ratio, that is 125. Now I am calculating the efficiency of the simple screw jack. That is efficiency equal mechanical advantage by velocity ratio. Here the mechanical advantage is 6.25. So velocity ratio is 125. 6.25 divided by 125. So 0.05. So in percentage, 5%. So this is the efficiency of a simple screw jack.